Hello dear students. Today in this video lecture we are going to discuss stoichiometric calculations and limiting reagent. Means we have to find out what is the limiting reagent and what is the quantity or the percentage or the amount of product formed from a given set of reactants. So we have a term stoichiometry. Stoichiometry simply means measuring the quantity or the amount of the substance in a given chemical reaction. So to define this stoichiometry, we have to first balance the chemical equation. Once we have this balanced chemical equation, the coefficient of the reactants in the balanced reaction are considered to be the moles. So we have stoichiometry means measuring amount of substance. Amount here we are dealing with mole. So for this, what is requirement is the reaction should be balanced. The reaction should be balanced equation, and in this we'll see mass to volume, mass, volume, mass, number of moles, etc. So how to convert mass into mole, how to convert mole into moles, how to convert mass into volume and volume into mass. And to define this, we have percentage yield of product. How to define the percentage yield of the product in a given chemical reaction? Suppose some initial conditions are given. From this initial condition, what will be the percentage of the product formed? And we'll also define a limiting reagent. So as far as percentage yield is concerned, so we have this percentage yield. Percentage yield is equals to experimental yield divided by theoretical yield multiplied by 100. Experimental divided by theoretical value multiplied by 100. So theoretical value is always greater than experimental value. So percentage yield cannot be 100%. The maximum is experimental value equals to the theoretical value. Or this is sometimes written as observed yield divided by calculated yield multiplied by 100. And as far as this mass, volume, mass, number of moles to mass, volume into mass is concerned, we have looked at this number of moles is defined as mass divided by molar mass. For gases, this is also defined as volume occupied by the gas at SPP divided by 22.4 liter. So if moles is given, then we can convert into mass, or if mass is given, then also we can convert into moles, or if volume is given, then also we can convert into moles, or we can also convert into mass. So this is the relation between mass volume, mass number of moles volume, number of moles and mass. So these type of calculation is what we call as stoichiometry. And to define the quantity of the product formed and how much of the reagent is left at the end of the chemical reaction, to define this quantity left, quantity reacted, and quantity of the product formed, we define a term which is known as limiting reagent. So let's see what is limiting reagent. So we have a term limiting reagent. So as the name suggests, limiting reagent, let me just explain you what is a limiting reagent. Whenever we have a chemical reaction between two reactants, suppose A and B, to give you product C. So the reaction is between the reactants A and B. So the reaction goes on till A or B is present in the reaction. If after certain time, if any of this reactant, either A or B, is completely consumed, if one of the reactant is completely consumed or no more present in the reaction mixture, obviously the reaction will stop. If the reaction stops, the formation of product will also stop. So that particular reagent in any given chemical reaction which controls or which limits the amount of product formation. That particular reagent which is controlling the formation of the product or which also limits the chemical reaction. That particular reagent is what we call as limiting reagent, because the moment this reagent is 100% consumed or no more present in the reaction will automatically stop. If the reaction stops, means formation of product will stop. So the quantity of the product formed in any given chemical reaction will be decided by this limiting reagent. Or we can also define in this way: a particular reagent which gives the least value of the product. So we have the components A and B. This reacts to give you product C. So we'll see out of this A and B which gives the least value of the product. So that particular reagent which gives you the least value of the product will also be defined as the limiting reagent, because that particular reagent which gives the least value of the product will be first consumed, 100% consumed in the reaction. So that will automatically control the chemical reaction and limits the product formation. So that particular reagent is what we call as the limiting reagent. So from definition point of view, this is defined as a reagent which is 100% or totally consumed in a reaction. So that particular reagent which is totally consumed in a given reaction is known as a limiting reagent. Or this can also be defined as a reagent which is present in lesser quantity in a reaction. So obviously both mean the same thing. The one which is present in lesser quantity will be 100% consumed in the reaction. So that one reagent is known as the limiting reagent. Or this can also be defined as a reagent which limits or controls the product formation. A particular reagent which controls or limits the product formation is also defined as limiting reagent. That means the reaction goes on as long as both the components are present in the reaction. If one of the component is 100% consumed, product formation will stop. So that particular reagent which is controlling the reaction, the moment that the reagent is 100% consumed, reaction will stop. So ultimately, reaction depends on the one which is present in lesser quantity or the one which is present totally 100% consumed. That controlling reagent is also known as the limiting reagent, or this can also be defined as the reagent which gives the least value of the product. So that particular reagent which gives the least yield or least value of the product, that reagent is also defined as the limiting reagent. So though we have different definition, but ultimately all this definition means the same thing. The only difference is the wording or the direction in which the reagent is defined. So whatever may be the definition of this limiting reagent, this is a reagent which is present in lesser quantity, which controls the reaction, which limits the product formation, and which is almost 100% consumed in the given chemical reaction. That reagent is what we call as the limiting reagent. So this is how we define limiting reagent. Now to define this limiting reagent, some condition is required. So let's see what is the condition required. Condition required is whenever we have to find the limiting reagent or the yield of product or how much of the particular reagent is left unreacted in a given chemical reaction. So the first thing is the reaction should be completely balanced. So the reaction should be completely balanced. So before starting this problem, we have to see whether the reaction is completely balanced or not. If not balanced, then we have to balance the chemical reaction. Without balancing the chemical reaction, we cannot define this limiting reagent. Once we cannot define the limiting reagent, then we cannot define the quantity of the product or the percentage yield of the product. So to define this limiting reagent, what we have to do is first the reaction should be completely balanced. Then second condition is definition is that particular reagent which is 100% consumed, which is present in lesser quantity. That is defined as the limiting reagent. But in a given chemical reaction, if both the reagents are 100% consumed, then the limiting reagent cannot be defined. So to define this limiting reagent, one of the reagent has to present in excess quantity and the other must be present in lesser quantity. But if both are 100% consumed in any given chemical reaction, so neither of them can be classified as limiting reagent. So in those cases, limiting reagent cannot be defined. So limiting reagent cannot be defined if both the reagent is totally consumed. So if both are 100% consumed, neither of them can be classified as limiting reagent. So one has to consume, the other one has to remain as excess. And the third condition is, though we have a balanced reaction, one of the reagent has to be classified as the limiting reagent. To define this limiting reagent, the given condition should be compared with the balanced chemical equation. The stoichiometric ratio, the mole ratio of the reactants in the balanced chemical equation should be compared with the given initial condition. Only then we can classify limiting reagent. If the given condition is more than that required from the balanced reaction, or if the given condition is less than the required in the balanced reagent, only then we can consider this to be limiting reagent. So third condition is the given means initial stoichiometric ratio should be compared with the stoichiometric ratio in the balanced equation. So by comparing the stoichiometric ratio in the given reaction condition with those present in the balanced equation, we will define the limiting reagent. If the given condition is more than the required, or if the given condition is less than the required, only then we can classify limiting reagent. So we have these three conditions to be satisfied for defining limiting reagent. So once we define this limiting reagent, we can easily identify the product. So let me give you some examples how to define limiting reagent. Suppose we have a reaction A2 combines with 3B and this gives you product C. This is the reactant C is a product. Assuming that this is the balanced chemical reaction, so in the balanced chemical reaction, 1 mole of A2 combines with 3 moles of B to give you product C. Now, the balance ratio is 1:3. For every 1 mole of A2, we require 3 moles of B, or for every 3 moles of B, we require 1 moles of A. Now, first condition, we are having in a reaction container, we are mixing with 2 moles of A2 plus 3 mole of B. In the reaction container, we are placed with 2 moles of A2 and 3 moles of B are placed in a container. Reaction takes place. So whenever A reacts with B, the ratio is 1:3 has to follow, resulting in the product formation. So out of these 2 moles of A2 and 3 moles of B, which one will be the limiting reagent and which one will be present in excess, and what is the product C form? So if you look at this, balance ratio says from balance equation. So balance equation says 1 mole A2 requires 3 mole B. So we have 1:3 ratio. For every 1 mole of A2, we require 3 moles of B. So initial quantity taken for A is 2 moles. So 1 mole A2 requires 3 moles of B. Then 2 mole will require how many? 6 mole B. So look at this. 2 moles of A2 will require 6 moles of B. But how many moles of B is present in the reaction mixer? Only 3 moles. So we are having 2 moles of A2 with 3 moles of B. But reaction ratio is 1 is to 3. For every 1 mole of A2, we require 3 moles of B. So theoretically, for these 2 moles of A2, the requirement of B is 6. The requirement of B is 6, but present is 3. So requirement is more than the initial present. That means this B is present in the limiting lesser quantity. So this is what we call as the limiting reagent. Therefore, limiting reagent is B. Why B is limiting reagent? B present in the solution is 3. The requirement is 6. So requirement is greater than the present or given condition. So B is present in smaller amount. So B is considered as a limiting reagent. So once we have this limiting reagent, we can identify how much of this product C will be formed and how much of A is left. So let A2 left means A2 is present as excess, B is present as limiting reagent. So again, to define how much of this A2 is left in this chemical reaction, again look at this, we have this ratio 3 mole 3 mole B requires 1 mole 3 mole B requires 1 mole A2. So present is 2 moles of A2 plus 3 moles of B. But ratio says for every 3 moles of B requirement is 1 mole. So out of these 2 mole, 1 will be consumed by 3 moles and how much is left? 1. So therefore A2 left is 2 minus 1, that is 1 mole of A is still unreacted. This 1 mole of A that is present as excess will have nothing to do in the chemical reaction. This will remain as unreacted. So that means out of this given 2 mole, only 1 mole will be consumed by these 3 moles of B and this will give you the product C. So this is the quantity of A left. Now let's see C formed. How much of this is formed? Now once we say if this product formation is controlled by the limiting reagent. So again we'll have to find the ratio of the limiting reagent and the product C. So if you look at this, in the balanced chemical reaction, every 3 moles of B gives you 1 mole of C. Therefore look at this, 3 mole B gives 1 mole C from the balanced chemical reaction. So the number of moles of C found is 1 mole. I hope the point is clear. So to define the quantity of product, we have to define the limiting reagent. To define this limiting reagent, we'll take the help of balance equation. So the given condition is compared with the balance ratio of the combining elements or the molecules or the reagents in the balanced chemical equation. So this is the way in which we define limiting reagent and the excess quantity and the amount of product formed. Take for the same reaction, second condition that tested is 2.5 mole plus 7.5 mole, 2.5 mole of A2 and 7.5 mole of B is taken in the container. Now we are changing the mole ratio. We are starting with 2.5 mole of A2 and 7.5 mole of B. Now both are present in the reaction container. The reaction takes place. Whenever this reaction takes place, the ratio should be 1:3. This results in the formation of the product. So again, look at this. We have this balance reaction. Balance reaction says 1 mole of A2 requires 7.5 mole B. 3 mole. 1 mole of A2 requires 3 moles of B. If 1 mole requires 3 mole, then 2.5 mole of A2 will require 3 into 2.5 mole of B. So this is 7.5 mole of B. So for this 2.5 mole of A2 that is present in the reaction container, how many moles of B is required? 7.5 moles of B is required. Given condition is 2.5 moles of A2, 7.5 moles of B. So given condition is exactly identical to the stoichiometric ratio. So that means both A and B will be consumed, 100% consumed. So in this reaction, both A2 and B will be 100% consumed. If both A and B is 100% consumed, then neither A nor B will be classified as limiting reagent. So in this case, limiting reagent cannot be defined. So that was the point which I have mentioned you earlier. If both are consumed, totally consumed or 100% consumed in any given chemical reaction, the limiting reagent cannot be defined. So to define this limiting reagent, one of the reagent has to present in lesser quantity, the other one has to present in larger quantity. So in the second case, A and B is 100% consumed, so neither A nor B can be classified as the limiting reagent. In this case, we're starting with 5 mole of A2 is which means 17 mole of B. We are starting with 5 mole of A2 and 17 mole of B2. Both are present in the reaction container. Then how much of product which one should be limiting reagent and how much of the product should be formed. So again, balance reaction says 1 mole A2 requires 3 mole B. So if 1 mole requires 3 mole, then given amount of A2 is 5. So 5 mole of A2 will require how many moles? That is 15 mole of B. So 5 moles of the reactant A2 will require 15 mole according to the Balance chemical equation. So the requirement of B is 15, but initially given condition is 17. So initial condition is greater than the requirement. That means B is present in excess. If B is present in excess, then A2 is present in limited quantity, so A2 will be limiting reagent. So therefore, in this case, limiting reagent is A2. So A2 is limiting reagent. If A2 is limiting reagent, then B left will be 5 moles will consume 15. So out of this 17, 15 will be consumed. So how much is left? 2. That is 17 minus 15, that is 2 mole of B is still left unreacted. This B will not have any contribution to the product formation C. If this is the case, then C formed. Just see what is C formed. Again, look at this. 1 mole gives you 1 mole. So 1 mole of A2 gives you 1 mole of C. Then 5 moles will give you 5 moles. So 1 mole A2 gives 1 mole C. So therefore 5 mole of A2 will give 5 mole C. So quantity of the product C form will be 5 mole. So this is how we define limiting reagent. And once we define this limiting reagent, we can define the product and we can also define the excess amount of the reagent left. In the second case, in which both are present equally, that means both are consumed 100% in the given chemical reaction. If we have this case, though we cannot define limiting reagent, but we can define the product C. So the quantity of product C will be same, either we define in terms of A or in terms of B. So look at this, in this case, C form. In the case of A, so 1 mole A2 gives 1 mole C. So therefore, 2.5 mole will give you 2.5 mole C. Take the other way around. 3 mole B gives 1 mole C. So 1 mole will give you 1 by 3 mole of C. Then 7.5 mole will give you 1 by 3 into 7.5, that is 2.5. So in both the case, we will get the same value. So this is the case in which both are consumed 100% in chemical reaction. If not, then we have to correlate with the limiting reagent. So this is how we define limiting reagent. Let me give you one more example here. Suppose we have a reaction, carbon monoxide gas combines with oxygen gas, and this gives you carbon dioxide gas. This is the reaction, carbon monoxide combined with oxygen to give you carbon dioxide gas. The reaction is not balanced, so we have to balance this way. So reaction is balanced. We have same number of carbons on either side, same number of oxygen on either side, so we have a balanced chemical reaction. Given condition says initial in this reaction container you are mixing with 300 ml of carbon monoxide is mixed with 100 ml of oxygen. In the reaction container, we introduce 300 ml of carbon monoxide and 100 ml of oxygen. Both are allowed to mix to give you this product C. So, what is the limiting reagent and what is the composition of the mixture? So, question says, what is the limiting reagent in this reaction and volume composition of the mixture? What is the volume composition of the mixture? So look at this, we have balanced chemical reaction in which the reactant is gas, product is also gas. This is given in terms of volume, so we can apply laws of chemical combination, that is Gernsback's law of combining volume. So if you look at this, we have 2 moles of carbon monoxide gas combining with 1 mole of oxygen gas, and this gives you 2 moles of carbon dioxide gas. So in this balanced chemical reaction, volume ratio is 2 volume of carbon monoxide always requires 1 volume of oxygen, and this always gives you 2 volume of carbon dioxide. This is the combining ratio, 2:1:2. This is balanced reaction. Given condition is 300, 100 ml. So first look at this define, which one is limiting reagent. So option says 2 volume of carbon monoxide requires 1 volume. So therefore 1 volume of monoxide requires half volume of oxygen, but the given condition is 300. So 300 ml will require, that is 150 ml. So 300 ml of carbon monoxide will require 150 ml of oxygen gas. The requirement of oxygen gas for 300 ml of carbon monoxide is 150, but in present in the reaction container is 100. So requirement is more than present in the reaction container. So therefore oxygen is present in lesser quantity. So it is a limiting reagent. So therefore oxygen is limiting the reagent. This is the requirement. This is the actual that is present. So we have to compare the requirement and the actual present. Requirement is more than actual, that is limiting reagent. If the requirement is less, quantity present is more. This is the one which is present in excess quantity. So we have this oxygen as limiting reagent. So once we have this oxygen as a limiting reagent, carbon monoxide will remain, and some of the carbon monoxide will remain unreacted, and these product carbon dioxide will also be decided by limiting reagent. Then the second part of the question is, what is the volume of carbon monoxide left unreacted? So look at it. Balance reaction says 1 volume of oxygen requires 2 volume of carbon monoxide. So every 1 volume of oxygen gas will combine with 2 volumes of oxygen. So 100 ml will combine with 200 ml of carbon monoxide. So for the 100 ml of oxygen, requirement of carbon monoxide is 200, but the present is 300. So therefore, volume of carbon monoxide left unreacted, that is initial minus amount consumed. So this is 100 ml reacts left unreacted. So out of this 300, only 200 will be consumed by 100 ml of oxygen. So this is the volume of carbon monoxide left. Now oxygen is 100% consumed, no more oxygen is left. So let's see how much of this carbon dioxide is formed. Again look at this. 1 volume of oxygen gives 2 volume of carbon dioxide. 1 volume of oxygen always gives you 2 volume of carbon dioxide. So 100 volume or 100 ml of oxygen will give you 200 ml of carbon dioxide. So therefore, volume of carbon dioxide formed in this given reaction is 200 ml. So we have looked at this 300 ml monoxide plus 100 ml oxygen on mixing. If reaction is allowed to take place, then oxygen is a limiting reagent. This is 100% consumed, so no more oxygen is left. Out of this 300 ml of monoxide, only 200 is consumed and the remaining 100% is left unreacted. And the volume of carbon dioxide formed is 200. So this is the volume composition. Monoxide left is 100 ml. Carbon dioxide formed is 200 ml. So this is how we find the limiting reagent, the excess quantity, and the amount of product formed in any given chemical reaction. Let's take up some more examples. we have this reaction nitrogen gas plus hydrogen gas. This gives you ammonia gas. The reaction is well balanced reaction. This process is known as Haber's process. This is a very good method for preparation of ammonia gas. So in Haber's process, nitrogen gas combines with hydrogen gas in presence of catalyst iron to give you ammonia gas. Initially in the reaction container, 30 ml of ammonia is mixed with 30 ml of hydrogen gas. So initially, the reaction container we introducing 30 ml nitrogen and 30 ml hydrogen. Question is, what is the limiting reagent and what is the volume composition? Volume composition for 50% product formation. What is the volume composition of nitrogen, hydrogen, ammonia if only 50% of the product is to be formed? Means not 100% product is formed. So we have to find this true. So if you look at this balanced reaction, one volume of nitrogen always combines with 3 volumes of hydrogen. This always gives you 2 volumes of ammonia. So balance equation says 1 volume of nitrogen volume ratio is to 3 volume of hydrogen is to 2 volume of ammonia. This is volume ratio. Means every 1 volume of nitrogen will react with 3 volumes of hydrogen. This will give you 2 volumes of ammonia gas. But the given condition is 30 ml of nitrogen, 30 ml of hydrogen. So if you look at this, first we have to define limiting reagent. 1 volume of nitrogen requires 3 volume of hydrogen gas, that is from the balance reaction. If 1 volume of nitrogen combines with 3 volumes of hydrogen, then 30 ml of nitrogen will require 90 ml of hydrogen. So the requirement of hydrogen for 30 ml of nitrogen is 90 ml. Requirement of hydrogen is 90, but the given condition is only 30. So requirement is more than the present in the reaction container. So that means hydrogen is the limiting reagent. So therefore, limiting reagent is hydrogen. So hydrogen is a limiting reagent. So hydrogen will be 100% consumed in the reaction, and this will define the quantity of the product formed. So first thing is we have defined this limiting reagent. Now the second part of the question is find the volume composition for 50% product formation. Means of the expected 100% product to be formed, only 50% is formed. If only 50% is formed, that means 50% of nitrogen will also be consumed, as well as 50% of hydrogen will also be consumed. So take this for 100%. If 100% consumption, so hydrogen is limiting reagent, nitrogen is the one which is present in excess. So therefore look at this. Let's define excess of nitrogen. So 3 volume of hydrogen require 1 volume of nitrogen. So for 1 will require 1/3. So 30 ml will require 10 ml of nitrogen. So requirement of nitrogen is 10. So out of these 30, only 10 will be consumed. So nitrogen left will be 20. So we have this nitrogen plus hydrogen ammonia. For this 100% product formation, hydrogen will be 100% consumed. So hydrogen consumed is 100%. So no more hydrogen is left. Nitrogen, for this 30 ml, how many nitrogen will be consumed? 10. If 10 ml is consumed, so how much is left? 30. So 30 minus 10, 20 left. Every 3 moles of hydrogen gives you 2 moles of ammonia. So 1 mole will give you 2 by 3. So 30 will give you 20. So this is nitrogen left, oxygen left, ammonia formed. So nitrogen consumed is 10. Hydrogen consumed is 30. That is hydrogen consumed, nitrogen consumed. It is nitrogen left, hydrogen left, and ammonia formed. But question says only 50% is formed. So 100% product is 20. So therefore, for 50% product formation, how much of ammonia should be formed? 10. 50% of 20, that is 10. If only 50% of product is formed, what is the quantity of hydrogen consumed? That is for 100% consumption. For 100% consumption is 30. So for 50%, half of this value will be consumed. For 100% product formation, nitrogen consumed is 10. So for 50%, how much will be consumed? 5. So this is consumed. If this is consumed, so therefore volume of nitrogen left, that is 30 minus 5, so 25 ml is left unreacted. Volume of hydrogen left, initial amount is 30. How much is consumed? 15. So still 15 ml is left unreacted. So 25 ml nitrogen left unreacted, 15 ml hydrogen left unreacted, and only 10 ml ammonia is formed. So this is how we apply limiting reagent by use of this stoichiometric ratio in the balanced chemical equation. Let's have some more examples to solve this limiting reagent. In a given chemical reaction, say we have this acetic acid combines with sodium bicarbonate, which gives you sodium acetate, hydrogen, and carbon dioxide gas. So we have a reaction: acetic acid, sodium carbonate, acetate, sodium acetate, water, and carbon dioxide. Given conditions are 15 gram of acetic acid is mixed with 6.3 gram of sodium bicarbonate. If this is the case, then what is the mass of carbon dioxide formed? Molecular mass of acetic acid is 60. Molecular mass of sodium bicarbonate is 84. So this is the question which is given. Acetic acid with molecular mass 60, sodium bicarbonate molecular mass 84, reach to give you sodium acetate had water and carbon dioxide. If in the given chemical reaction 15 gram of acetic acid mixed with 6.3 gram of sodium bicarbonate, then what is the mass of carbon dioxide formed? If you look at this is a well-balanced reaction. 1 mole acetic acid combines with 1 mole bicarbonate to give you 1 mole carbon dioxide. So every 1 mole of acetic acid requires 1 mole of sodium bicarbonate. So first thing is to define the quantity of product form, we have to define the limiting reagent. So the problem involves finding the limiting reagent. So if you look at this, 1 mole of acetic acid requires 1 mole sodium bicarbonate. So 1 mole acetic acid means 60 gram requires 84 gram of sodium bicarbonate. So 1 gram of acetic acid will require 84 by 60. But the actual quantity of acetic acid given is 15. So 15 gram will require 84 into 15 divided by 60. So this is 4. So the requirement of sodium bicarbonate for 15 gram of acetic acid is 21 gram. The requirement is 21 gram, but how much is present? Only 6.3. Out of the requirement 21, only 6.3 is present. So therefore, sodium bicarbonate is the limiting reagent. So therefore, our limiting reagent in the reaction is sodium bicarbonate. Now we define in terms of mass. We can also convert in terms of number of moles and compare the number of moles also. Both are same, will give you the same value. So once we have this limiting reagent, the product formation will be decided by this limiting reagent. And look at this ratio. 1 mole of this limiting reagent bicarbonate gives you 1 mole carbon dioxide. 1 mole sodium bicarbonate gives 1 mole carbon dioxide. Mass of 1 mole bicarbonate is 84 gram. So 84 gram gives you carbon dioxide 1 mole is 44 gram. So therefore 1 gram will give you 44 by 84, and the quantity of bicarbonate taken. What is the excess amount left and what is amount of carbon monoxide formed? We have to find this thing. We have this balance reaction. Carbon combines with oxygen to give you carbon monoxide gas. Quantity taken is 24 gram of carbon, 96 gram of oxygen. Then what is the limiting reagent? How much of the quantity is left and what is the amount of carbon monoxide formed? So if you look at this balance reaction, so number of moles of carbon, that is 24 divided by 12. So we have 2 moles of carbon is taken. Number of moles of oxygen 96 by 32. Molecular mass is 32. So this is 3. So 24 gram corresponds to 2 mole. 96 gram oxygen corresponds to 3. So we are having 3 moles of oxygen and 2 moles of carbon. So Balance reaction says 2 mole carbon requires 1 mole oxygen. So every 2 mole carbon requires 1 mole of oxygen. Given quantity of carbon is still 2, so these 2 moles of carbon, according to balance reaction, will always require 1 mole of oxygen. So requirement of oxygen is 1 mole, but actual present is 3. So therefore, carbon is a limiting reagent. If carbon is limiting reagent, oxygen is present in excess quantity. So number of moles of oxygen left, that is 3 minus 1. So still 2 mole is left unreacted. So therefore, mass of oxygen left is number of moles into molar mass. So 64 gram of oxygen is left unreacted. Now, what is the quantity of product formed? So look at this, 2 mole carbon gives you 2 mole carbon dioxide. 2 mole carbon gives 2 mole monoxide. So means 1 mole will give you 1 mole. So 2 mole gives you 2 mole, 1 mole gives you 1 mole. The quantity of carbon taken is 2 moles. So how much of carbon monoxide will form? So therefore, number of moles of carbon monoxide form is 2, or mass of carbon monoxide form is 2 into 28, that is 56 gram will be formed. So this is how we correlate with the balanced chemical reaction. Let's have some more examples. Question says 1 liter of a mixture of carbon monoxide and carbon dioxide is taken. So we have a container. This container contains 1 liter of carbon monoxide and carbon dioxide. It is passed through a tube containing red hot charcoal. The volume now becomes 1.6 liter. Initial volume of mixture is 1 liter. Now this is passed through the red hot charcoal. After passing through, the volume of gas becomes 1.6 liter. Find the composition of mixture. That means in 1 liter, how much of carbon monoxide and how much of carbon dioxide is present. So we have to find the volume mixture. Now the reason is this: when a mixture of monoxide and dioxide is passed through red hot charcoal, the reaction which is taking place is carbon dioxide gas will react with red hot charcoal, and this is converted into carbon monoxide gas. Carbon monoxide will not react with carbon, but carbon dioxide will react with carbon, and this is converted into carbon monoxide. If suppose we have this 1 liter, so this 1 liter is a mixture of some monoxide and some carbon dioxide. So if you look at it, let the quantity of carbon dioxide in this 1 liter be suppose x ml. If x ml is carbon dioxide, then carbon monoxide is 1000 minus x. So look at this. Let the volume of carbon dioxide in the mixture will be x ml, then the volume of carbon monoxide will be 1000 minus x ml. Now look at this balance reaction. Carbon dioxide, one volume gives you how many volumes of carbon monoxide? Two volumes. So therefore, one volume of carbon dioxide gives two volume of monoxide. So therefore, x ml will give you twice x ml of carbon monoxide. That means carbon dioxide is consumed to give you carbon monoxide. So therefore, look at this total volume after the reaction. That is volume of carbon monoxide formed plus volume of carbon monoxide present initial. So this volume, that is twice x, that is the volume of carbon monoxide formed, and volume of carbon monoxide left is 1000 minus x, so this becomes ml. So therefore x plus 1000 is equals to 1600. So therefore x is equals to 600 ml. So what is the volume of carbon dioxide? 600. So therefore volume of carbon dioxide in the mixture is 600. Then volume of monoxide present in the mixture is 400. So 1 liter of the mixture contains 600 ml of dioxide and 400 ml of monoxide. So we have to see out of the given which one has to react with the reagent, that is charcoal, which is nothing but a carbon. Further question says equal masses of zinc and iodine were allowed to react. Equal masses of zinc and iodine were allowed to react when iodine is converted to zinc iodide. Question says, what is the limiting reagent? And second, what fraction by mass of the excess reagent is left unreacted? Zinc atomic mass is 65 iodine is 127. So a reaction says zinc and iodine were allowed to react to form zinc iodide. Condition is mass of zinc taken and mass of iodine taken is same. So first thing is we have to find what is the limiting reagent and what fraction by mass of the reagent excess is left unreacted at the end of the reaction. So for this part we have to write down the reaction. The reaction is we have zinc combines with iodine and this gives you zinc iodide. So reaction is well balanced. So ratio says 1 mole, 1 mole. React to give you 1 mole, so ratio is 1:1 molar ratio. But the given condition says this is x gram, this is also x gram. So x gram of zinc reacts with x gram of iodine. Then what is the limiting reagent and which one is left unreacted? And what is the fraction of the reagent left unreacted? So therefore look at this. Number of moles of zinc is mass divided by molar mass. Number of moles of iodine is mass divided by molar mass. Atomic mass is 127, so molar mass is 254. Balance reaction says for every 1 mole of zinc we require 1 mole of iodine. So number of moles of zinc is x by 65. Number of moles of iodine is x by 254. So therefore look at this. 1 mole zinc requires 1 mole iodine. So therefore x by 65 zinc will require x by 65. The requirement is x by 65 but initial present is x by 25. So this x by 65 is greater than x by 254. So requirement is more than the present. So therefore limiting reagent is I2 is the limiting reagent. So if I2 is the limiting reagent, zinc is present in excess. So what is the fraction of zinc that remains unreacted? The fraction by mass. So therefore look at this. Number of moles of zinc left unreacted is initial amount minus amount reacted x by 65 minus x by 254. So out of this x by 65 only this will be consumed, so some remaining unreacted. So therefore fraction of zinc left, that is number of moles left, zinc left divided by number of moles of zinc present initial, that is the fraction of moles of zinc left. So this is x by 65 minus x by 254 divided by x by 65. So in terms of mass, this is the mole ratio, number of moles left. Now to define in terms of mass, multiply this moles by gram atomic mass, that is 65. So this is the fraction of zinc that is left, or we can say look at this. This is x will cancel out. So 1 minus 65 by 254, that is mole fraction, mole fraction of mole left. So in terms of mass multiplies, that is 1 minus 65 by 254 into 65, that is fraction by mass that is left. So this is how we define limiting reagent, and from this limiting reagent we left the other calculations. So these are the problems in which we use the concept of limiting reagents. So I hope the concept of limiting reagent is known to you. So for every chemical process, let's first we have to balance the chemical reaction, and from the balanced chemical reaction find the limiting reagent, and to find this limiting reagent you have to compare the given stoichiometric ratio with the balance ratio present, and then correspondingly we can find what is the product form, what is the reagent left, and how much of this is left and reacted. Thank you.